In Chapter 6, exercises 20 and 21, they're asking you for the formula of some molecular or covalent compounds. A molecular compound and a covalent compound are the same thing, and they mean that you're combining two non-metals. So non-metal and a non-metal combined give you a covalent compound. Okay, so these compounds there are two parts to them. The first is that they list the elements you have. For example, in A, they give you carbon and they give you chloride. The second part are prefixes. And so those prefixes are either invisible or they're given right in front of the element. Now, most of the prefixes that will be written explicitly, they're all going to represent subscripts that will come after that element. So, for example, the prefix tetra would represent a subscript of 4 at the bottom right of whatever element that it was a prefix for. The one exception is for the first element in a compound. If the first element in a compound doesn't have a prefix, then the implied prefix is mono, and so you only have one of those elements. Okay, so let's dive in and see what this looks like, translating these names into formulas. First thing we're going to do is to take the name and write the element that it is. So carbon is sort of in the top right, and you can see that the symbol on the periodic table is a capital C. The other one is chlor. Now chlor is referring to chlorine, which is on the right, and the symbol for that is Cl. Okay, so that's the elements. Now let's think about the prefixes and what they tell us about the subscripts. Subscripts would go at the bottom right. Okay, so there is no prefix in front of the first element, and that only happens when you have one of that element. You don't have to write the subscript 1, and so we're good with that. The next element, the prefix is 4. The prefix is tetra, and what tetra means is that at the bottom right of that element, chlorine, you'll have a 4. That's what this tetra is trying to communicate. So overall, the symbol, or the formula for this covalent or molecular compound would be CCl4. That is carbon tetrachloride. Okay, let's try B. First let's write the elements, then we'll worry about the prefixes. Carbon. Carbon is in the top right of the periodic table. It has the symbol C. Ox. Ox is referring to oxygen. Oxygen is in the top right of the periodic table. It has the symbol O. Okay, now let's think about the prefixes. The first element doesn't have a prefix. That's only the case when you have one of them. The second element has the prefix mono, and so it also has only one. Now you don't have to write the ones, because by writing the symbols of the elements, you know you have one of them. So you can just write capital C, capital O. That is carbon monoxide. Okay, let's do phosphorus trichloride. First, we want to write down the symbols for these elements. The first one is phosphorus. Phosphorus is in the top right of the periodic table. It has a symbol of P. So that's the first thing. The second thing is chlor. Chlor is referring to chlorine. Chlorine is on the right side of the periodic table and has a symbol of Cl. Okay, so those are our elemental symbols. Now, let's look at the prefixes and see what they tell us about the subscripts. The first element doesn't have a prefix, and that means that you only have one of them, and so that's what that subscript would be. The second element has a prefix tri, and tri means that the subscript should be 3. So when you put all of this together, the compound you would get would be PCl3. And so that is the formula for phosphorus trichloride. Let's try dinitrogen tetroxide, D here. So first let's write the elements, then we'll worry about the prefixes and what they tell us about the subscripts. First is nitrogen. Nitrogen's in the top right of the periodic table. The symbol is a capital N. Then ox. Ox is referring to oxygen. It's right next to nitrogen, to the right of it. The symbol is a capital O. So much for the elements. Now let's think about the prefixes. So the prefix in front of the first element is di, and that means that the subscript is going to be 2. The prefix in front of the second element is tetr, and that means that the subscript after that element is going to be 4. So the formula for dinitrogen tetroxide would be N2O4. That's dinitrogen tetroxide. So that's question 21. Exercise 20, or that's exercise 20. Exercise 21 is really the same sort of thing. So let's round that off. We're looking for the formula of a molecular compound. Molecular or covalent compounds use these prefixes to tell you about the subscripts after each element in the formula. So first, let's write down our elements. Sulfur. Sulfur is a capital S. It's in the top right underneath oxygen on the periodic table. So we'll write S. Then we have ox. Ox is referring to oxygen, which is just above sulfur in the top right, and the symbol for that is a capital O. Okay, so much for the symbols. Now let's think about the prefixes. There's no prefix in front of the first element, and when that's the case, you only have one of that element. The prefix in front of the second element is di, and that means that you have 2 of that element, that the subscript at the bottom right of that element will be a 2. So overall, the formula for sulfur dioxide will be SO2. Notice how I didn't have to write this 1 here, because just by writing sulfur, I know that I have 1 of them. So SO2 is the formula for sulfur dioxide. Okay, B, silicon tetrachloride. First things first, let's write down the symbols for these elements. So silicon is just underneath carbon on the periodic table, so the sort of top right, and the symbol for that is Si. Chlor is referencing chlorine. Chlorine is on the right side of the periodic table, and sort of the top right. The symbol is Cl. Okay, so much for the symbols. Now let's think about the prefixes and what they tell us about the subscripts. There is no prefix in front of silicon, the first element. When there's no prefix in front of the first element, it means you only have 1 of them. The prefix in front of chlorine is tetra, and because the prefix is tetra, you know that the subscript below, at the bottom right of chlorine will be 4. So putting all of that together, silicon tetrachloride would be SiCl4. That would be the chemical formula for that molecular compound. All right, C, iodine trifluoride. First thing we're going to do is to figure out the symbols. Iodine is at the bottom right of the periodic table. It has the symbol capital I. Fluor is referring to fluorine. That's at the top right of the periodic table. And it has the symbol capital F. Okay, so much for the chemical symbols. Now, let's think about the prefixes and what that tells us about the subscripts. The prefix in front of iodine, there is none. And so that means that you only have 1 of them. When you don't have a prefix in front of the first element, you only have 1. The prefix in front of fluorine is tri, and that means that at the bottom right of fluorine, we're going to have a subscript of 3. So putting all of that together, the chemical formula will be IF3. That's iodine trifluoride. All right, last but not least, D. So dinitrogen oxide. Now technically this should be dinitrogen monoxide. So let's actually write that in. Dinitrogen monoxide. Okay, so first things first, let's write the symbols for the elements. The first one is nitrogen, and the symbol for nitrogen is a capital M. It's in the top right of the periodic table. So capital N. Then we have ox, and that's referring to oxygen, which is just to the right of nitrogen on the periodic table in the top right. So a capital O is the symbol for that. Okay, now let's think about the prefixes. In front of nitrogen is the prefix di, and the prefix di is telling you that the subscript at the bottom right of nitrogen will be a 2. The prefix in front of oxygen would be mono, And that's telling you that at the bottom right of the oxygen, you'd have the subscript of 1. So putting all of this together, you would have N2O. Notice I don't have to write the 1 because by writing the capital O, I know I have 1 oxygen. So N2O is dinitrogen monoxide. And so you can see how the name of a molecular compound gives you all the information you need to write the chemical formula that gives you the ratio of elements to each other in that compound.